Please welcome the Vice President of Database Services at AWS, G2 Krishnamoorthy.
Good morning and welcome. Thank you for joining us this morning and hope you're having a fabulous re:Invent so far. Let's talk some databases. On behalf of the entire AWS team, today Jeff and I are really excited to share with you some of the innovations we have worked on this year. What we work on is based on what we hear from you, our customers. Now, I've been building databases a long time. In fact, I got started in the last millennium as a young engineer. And I'm more inspired today than ever before by the opportunities that we have to make our lives better with data. That's why we are driven to innovate and make databases effortless for you, builders, so that you can focus your time and energy in building the next generation of applications. Today, we'll hear inspiring stories about the art of the possible from United Airlines, NFL, and BMW, and how they have built it on AWS databases. In the last year, we delivered hundreds of new capabilities, features, and services based on your requests. To highlight a few, we launched Aurora PostgreSQL Limitless Database, Valkey in Elasticache and MariaDB, and the one-click ability to turn Aurora and Neptune into your knowledge base in Bedrock. So what's coming next? Database is a critical building block in your applications. And it's part of the bigger picture of our vision for data analytics and AI. Matt talked about this on Tuesday in his keynote. We want to provide you with a no assembly required experience to unlock value from all your data, no matter where it lives. Could be on AWS, could be in another cloud, could be in a SaaS application, or in your premises, so that you can invest all your effort and hours innovating in your applications and not stitching together various systems. An example of this is Zero ETL. It enables you to make your application data available for analytical and ML use cases in near real time with just a few clicks. We are really excited about the performance our customers are seeing with this integration. For example, Motive Technologies consolidate their multiple data pipelines with Zero ETL integrations to make their data in DynamoDB and RDS MySQL available in Redshift for analysis. And they saw their data freshness go from hours to just 15 seconds. And we are expanding these integrations. We added integrations from popular SaaS applications such as Zendesk or SAP. We added integrations to SageMaker Lakehouse in addition to Redshift for many data sources, including DynamoDB. And we are expanding the data sources in 2025. Every day, our teams wake up and think about what we can do to make databases as effortless as possible for you. We want you to focus more of your time innovating in your applications and less on patching and scaling or managing the underlying database instances. Now, we have been on this journey for 15 years. We launched the first fully managed databases to remove the heavy lifting involved in managing database instances. Then we launched serverless to eliminate the need to plan, provision, and manage database capacity as your application scale changes. And we are doing more. We are investing in simplifying business continuity. We are investing in accelerating business continuity, expanding scalability, and improving ease of use. Let's dig into business continuity. To serve the needs of the most demanding applications, our customers are asking us to make their databases be in multiple regions, be always available, and with minimal impact on performance and cost. So over the last decade, we have built many innovations in Amazon Aurora to simplify business continuity. And on Tuesday, Matt announced the next big step we are taking, the preview of Aurora DSQL, a new database in Amazon Aurora alongside MySQL and PostgreSQL. Aurora DSQL is a new serverless distributed SQL database with the fastest reads and writes for always available applications. Applications can leverage Aurora DSQL's strongly consistent semantics, 5 nines of multi-region availability, and the automatic recovery in the rare event of failing to connect to a regional endpoint. This morning, Werner shared some of the innovative capabilities that power Aurora DSQL, such as multi-region journal or the high-precision clock in Amazon TimeSync. Aurora DSQL enables an active-active architecture for your mission-critical applications so that they can be always available. Your application can read and write all its data from any DSQL endpoint with strong consistency. All transactions written in any region will be synchronously reflected in all other regions. So let's spend some time and dig into how we designed Aurora DSQL to make it effortless for you to build distributed applications that are always available and also high performance and highly scalable. OK, so first thing, typical distributed databases, they break up data into shards. and each shard is managed by an assigned leader. So to ensure strong consistency, all reads and writes would negotiate with the leader. Let's call it the shard leader design. And as the application scales, these shards need to be further split up. Like, while the strategy can work well, it's not flexible enough. It can be difficult to get the sharding configuration right, and during resharding, the system could slow down or even become unresponsive, impacting your application's availability. So we designed Aurora DSQL to offer limitless scaling by having no single leader. This is a far more flexible design and allows us to dynamically scale reads and writes up or down for optimal load balancing and best availability. Each system in the database, could be the query processor, the transaction system, or the storage system, scales independently for exceptional elasticity without compromising performance. This design allows the database to adapt to different application patterns dynamically, read-heavy or write-heavy, complex queries or high transaction rates, optimizing both performance and cost. Now, Aurora's DSQL compute runs as small ephemeral microservices, just like Lambda. In fact, we built it on the Firecracker micro virtual machine that powers Lambda. So this allows Aurora DSQL to automatically scale fast and achieve high utilization for workloads of all sizes. And each storage partition can have unlimited number of strongly consistent replicas without impacting the write performance. So read-heavy workloads can scale with great performance since all reads can be running locally, even in multi-region deployments, without giving up strong consistency. So unlike in the shard leader design, you don't have to trade off strong consistency for good performance on your read-heavy workloads. Now, since we have a microservice design, Aurora DSQL can deploy each component of the database independently. Each component workload, like the query processor, is distributed over many hosts and can seamlessly move from one host to the other. So Aurora DSQL can deploy changes to any components without customer impact. There is no more maintenance windows for your database. For example, the query processor can be updated to a newer, minor version of the Postgres-compatible engine without disrupting the in-flight query. New connections can automatically pick up the new version. In a shard leader design, even a minor version update would require a complex leader failover, and that often risks your application's availability. In Aurora DSQL, we can do this transparently, and you don't even have to think about it. So Aurora DSQL is designed to effortlessly scale, update, and self-heal while keeping your application to be available with consistent performance. When your application needs to scale up, Aurora DSQL will automatically add more resources, more compute, more storage. When you need more requests, it'll add more query processors. When you need more reads, it'll add more replicas. And when you need more writes, it'll add more journals. And when the application scales down, your Aurora DSQL would reduce these query processors or storage replicas just as seamlessly as it added them. It's truly hands-off scaling database, forged from the 15+ years of our learnings in building and operating large-scale services such as S3, Lambda, Aurora, and DynamoDB. So what else actually impacts availability of an application? Let's talk concurrency control. Traditional relational databases, they use locks, transaction locks, rows, or tables to constrain conflicting changes from other transactions that may be happening concurrently. This is important for guaranteeing consistency and isolation, the C and I in ACID semantics. But this design has scalability challenges as the number of transactions increase from hundreds to thousands or even millions. And just All it takes is one slow or stuck transaction to grind your whole application to a halt, causing unavailability. So we have designed Aurora DSQL with optimistic concurrency at its core. No locks are needed for consistency or isolation. Let's also look at how this enables the fastest reads and writes. In Aurora DSQL, all statements will run locally, and only the transaction commit goes across regions, and just once per transaction, regardless of one statement in a transaction or 1,000. And a single transaction can never disrupt the whole application by holding on to too many locks or holding on to them for too long. And this design enables Aurora DSQL to maintain high performance and strong consistency even in multi-region deployments for workloads of any size and complexity. And one more thing. In a typical multi-region design, when an outage happens, could be due to a host is down or a network cable is cut, could be due to Mother Nature or human error. The decision to fail over or not to fail over, that's a tough one. Manually failing over to the secondary could lose recent transaction because the secondary may not have been fully caught up to it. You could wait for the primary to recover and avoid losing these transactions, but that causes application to be unavailable. Both bad options, lose data or take downtime. With the strong consistency in Aurora DSQL, there is no concept of primary or secondary. If a region is unreachable, application can simply point to another regional endpoint and continue operating. No downtime and no data loss. And when the region recovers, it'll automatically heal. No manual operations are required, and your application remains available throughout. Now, this need for multi-region strong consistency with minimal impact on performance applies to all databases, including NoSQL databases such as DynamoDB. DynamoDB is our first serverless NoSQL database and offers single-digit millisecond performance at any scale. And it's also the first multi-region database with the launch of global tables back in 2017 for applications that need 5 nines of availability with eventual consistency across regions. And tens of thousands of customers are using DynamoDB global tables for use cases such as publishing social media activity or streaming video usage. And I'm really excited about the preview of Amazon DynamoDB global tables with strong consistency across regions. With this feature, data written is persisted across multiple regions synchronously, enabling you to deploy your mission-critical applications that need read-after-write consistency in multiple regions with 0 changes to your application code. And DynamoDB global tables with strong consistency will synchronously write data to at least 2 regions. And your application can always read data from any regions and expect to get the latest value. Let's see this in action with an example. Let's consider a bank. A bank has customers with credit cards, and they need to track the available credit, And they need to ensure that this credit tracking application, if it is interrupted in one of the regions, they can shift the card processing automatically to another regions and not lose any transactions. So when a customer makes a purchase, the credit tracking application updates the available credit in a row in a global table with multi-region strong consistency. And the global table would persist that write in the multi-region journal, and it can acknowledge back to the application. So the write is committed. And the application can simply read and modify available credit data in any region and not worry about data consistency. The read from any other region is going to return the correct available credit amount. And DynamoDB is using the same innovative multi-region journal that is used in Aurora DSQL to achieve this. Each region can process the write in the correct order locally without coordinating the other regions. And getting started with this feature is simple. With a single click, you can add multi-region strong consistency to your DynamoDB regional tables. No changes to your application is needed. And it is more cost-effective than ever to use DynamoDB. We innovated to be more efficient in DynamoDB, which means new cost savings for you, our customers. We recently announced significant price reductions. On-demand pricing is now 50% lower, and global table writes pricing is now up to 67% lower. Now, when you're running a distributed application in multiple regions, then it's a question of when, not if, something is going to fail. Aurora DSQL and DynamoDB global tables with multi-region strong consistency makes it effortless to failure-proof your application with no data loss and no downtime. Finally, for customers who need in-memory speeds and multi-region resiliency, we have Amazon MemoryDB multi-region, an active-active multi-region database with microsecond read latency and 5 nines of availability. And to achieve this in-memory performance, we replicate writes asynchronously. Amazon supply chain optimization team is dealing with supply chain challenges at Amazon scale, and they are using MemoryDB multi-region to significantly reduce their operational overhead without compromising on the in-memory performance. With all these announcements, we now have 4 databases that gives you active-active multi-region capability to support your varying application needs: Aurora DSQL, DynamoDB global tables, MemoryDB, and key spaces. Adding the multi-region active-active capability to our databases is one of the many ways we are making databases effortless for you to build and operate your applications. And you're always in control of where your data is residing. We will continue to strive to offer you the richest and the most capable databases for all your applications. Now, I'm excited to welcome Sanjay Nair, Managing Director of United Airlines, joining us on video to share how his teams have modernized their customer reservation systems using AWS Databases. So let's listen to Sanjay.
Hello, everyone. My name is Sanjay Nair, and I am the Managing Director of Data and AI Engineering at United Airlines. I'm delighted to share United's vision of being your airline of choice and how we achieve that vision through innovation and data. United Airlines is dedicated to creating a best-in-class customer experience with our vision of connecting people, uniting the world. We operate one of the largest airline networks globally, offering over 4,900 daily flights that transport passengers and cargo across 6 continents. In partnership with AWS, we aim to achieve our vision of making air travel more seamless through digital solutions that improve how people travel the world. Back in 2021, United chose to partner with Amazon Web Services on our journey to the cloud with a broad goal to improve customer experience and keep planes running on time. A central aspect of our initial strategy with AWS is real-time data capabilities. Now, why is real-time data important? Customers increasingly want and crave information about their flights in a language they understand, not airline jargon. Our employees also rely on data-driven decisions supported by governance and risk guardrails. Implementing a real-time data strategy has enabled our employees to make decisions based on trusted, real-time data about flight routes, the reason for delays, and to support customers in making their connections. In 2023, United achieved a 1-year revenue growth of 19.5%, and a net margin of 6.3% versus an industry average of 4%. Our customer experience, based on the Net Promoter Score, which improved by 4% yearly, was nearly double the industry average. But we are not done yet. United has been on a multi-year modernization journey with AWS to build an integrated end-to-end active-active data infrastructure to support real-time decision-making and anticipate customer needs. For example, if United knows that a passenger's flight might be delayed and observes that the passenger takes this flight regularly, we can anticipate the passenger's need to rebook the flight and offer real-time booking changes in response to the delay. Now let me walk you through our journey, how we perceive data, our current status, and more importantly, our future ambitions. Integral to our data foundation are three pillars: data integrity, high availability, and operational excellence that allow us to quickly scale to meet the volatile demand due to unplanned events such as weather and our business's growing needs. Now, data integrity is critical for keeping data secure, accurate, and up-to-date throughout the process, even during peak travel times when we can receive millions of requests per hour. Highly available and resilient infrastructure is essential to ensure that our applications remain operational 24/7 and can endure weather events such as winter storms that lead to power and network outages. We must be prepared to make swift decisions and recover effectively from both human and system errors to provide the best customer experience. We are committed to continuous operational excellence to enhance efficiency and reduce RTL. Our goal is to eliminate manual interventions and minimize downtime. Databases are fundamental to any data infrastructure. At United, we utilize AWS purpose-built databases for enhanced resiliency and scalability throughout our cloud data architecture. Today, we run over 2,500 database clusters across Amazon Aurora, DocumentDB, Elasticache, and Neptune, and have about 500 DynamoDB global tables enabled. We store more than 15 petabytes of data and run millions of transactions per second. Now let me walk you through a few examples. United's passenger service system is the heart of the airline. It consists of shares, a 53-year-old mainframe developed in TPF, along with over 200 additional applications that enable United to function effectively beyond the constraints of shares. Within shares resides the authoritative source for ticketing, seating, baggage, and reservations, among other essential processes. Our mainframe shares is processing 657 million messages daily at an average of 7K to 8K million instructions per second. Now, in the past 2 years, we have modernized and rebuilt over 400 applications using AWS native services, focusing on creating value for the airline. Throughout our growth strategy, United Next, we plan to add more than 700 new airplanes to our fleet by 2033. And we have begun to modernize critical components that live in shares. To effectively handle the growing demand while delivering outstanding customer service, we have partnered with AWS to rebuild the core of our airline, our ticketing and reservation system. We transitioned from on-premise infrastructure to AWS, where we manage all reservations and process orders. During peak periods, such as the holiday rush, we process millions of requests every hour. Our passenger name record system connects you and links our entire operations team behind the scenes, including our customer service, in-flight crew, baggage handlers, gate staff, and more. In designing the reservation system, we aim to create a unified platform that integrates airline ticketing, lounge reservations, hotels, rental cars, and ancillary services such as meals and Wi-Fi into one cohesive system. We transitioned from a traditional ticket-based system to an order-based system using Amazon Document DB. We selected Amazon Document DB because it is a fast, highly available, and scalable document database that simplifies operations as a fully managed service. It is the primary OLTP database for storing active reservations records up to 18 months in advance. This includes add-on services such as seat upgrades, food choices, family seating, and early check-ins, all in the same order. We utilize Amazon Aurora to store flight reservation histories for up to 7 years. This serves as the primary database for call center agents and automated IVR prompts, allowing us to address customer concerns in real time. We also use Amazon ElastiCache as a caching layer to provide quick access to historical data and conversations, enhancing our customer support. United now operates its entire reservation system using AWS's purpose-built databases, which are deployed for continuous business operations. This setup provides the resilience, scalability, and flexibility needed to grow with our business needs. Seating is a crucial aspect of reservations, and if it isn't managed properly, it can negatively impact the customer experience. We opted for DynamoDB Global Tables as our primary system for seating assignments due to its exceptional scalability and active-active multi-region high availability, which offers single-digit millisecond latency. This lets us quickly and reliably write and read seat assignments, ensuring we have always the most up-to-date information. We are excited to explore Amazon DynamoDB Global Tables with strong consistency and learn how we can further enhance the customer experience. Not only have we used AWS purpose-built databases for customer-facing applications, but we also use them to improve our internal operations. Have you ever wondered what happens to your bags once you check them in? At United, our bag manager system will track their every movement from when you check them to when they're delivered to the carousel. On average, your bag is scanned 50 times before it reaches you. That is, our system tracks over 1.5 million bag scans on any given day. To do this on a global scale, we chose Amazon DynamoDB for Bag Manager because it supports the requirements for real-time data, 24/7 availability, and the ability to easily ingest the constant stream of data from partners and other internal tools. With DynamoDB, we can easily separate read and write workloads for faster performance. As a serverless database, our developers can focus on writing efficient APIs without worrying about system capacity or database maintenance. Now, real-time data is essential for coordinating our passengers, ground teams, in-flight staff, and support teams. We aim to measure approximately 250 data points in real time to support effective decision-making throughout the organization. We have made significant progress in our modernization journey, and we will continue to work behind the scenes to transform our operations, including crew scheduling, using AWS purpose-built database services. This also includes improvements to planning and faster turnaround times for our aircraft. So, for those flying home after reInvent or traveling for the holidays, sit back, relax, and thank you for flying United. Thank you, everyone.
Thank you, Sanjay. It's an incredible story of modernization and preparation both for increasing their efforts to make customers able to use their systems, as well as prepare for scale. So I just wanted to take a moment and thank Sanjay. So again, thank you. All right, hi, I'm Jeff Carter, and I'm a VP for databases within AWS. And let's talk some more about some of the features that we have been releasing this week. The first, in our commercial space, we're going to focus in on scalability in this section. And one of the things that was announced in September this past year is a new relationship between Oracle and AWS. And making it simple, what we are doing is we're taking Exadata systems and we're going to be putting it in AWS data centers. Now, why would we do this? The key is the Exadata system runs some of the hardest workloads in the database industry. And to get the power of Exadata systems, we want to reduce the latency between the application tier and the Oracle Exadata tier. So by putting them physically in our data centers, we're going to minimize the latency and maximize your performance. This week, we're announcing Oracle Database at AWS. This is that program, and it's available in limited preview. So in just a handful of months, we have been able to get this ready to go and customers to use it. We are building it out across data centers throughout the US and around the world. And as we do that, we will get so that we can have redundancy for these very difficult workloads. And when we do that, we will be able to go fully generally available. But we're very excited by this. And this gives you the opportunity to combine the value that you have in your Oracle systems with the value that you have in your AWS systems and to be able to get the best of both worlds. We'll make it very easy and quick to be able to migrate the data into these Exadata systems, and we'll offer simplified management to be able to operate them. Other things that we will add in is things like zero ETL. And zero ETL, if you would like to do analytics in your Exadata system, of course you're welcome to do that. But if you want to be able to combine that data with other data that you have within AWS, zero ETL will help you get it into SageMaker Lakehouse. And from there, you can do things like machine learning and generative AI on that data. I was having this discussion with a customer yesterday. The customer was from Japan. And at the end, when we talked about this, the comment that I heard from the translator is, "That's awesome." And I hope you feel the same way. In addition, we're going to have collaborative support. We've been doing this for over a decade with RDS Oracle, but we're going to have collaborative support, so you can call AWS for support, or you can call Oracle for support, and we will each own our pieces and make sure that we invoke the other party whenever needed. From a purchasing perspective, you're going to get a single bill through AWS, and you will get credits for AWS private pricing agreements and for Oracle support rewards. And we are going to make it so if you're familiar with the AWS side, they're going to be, most of the aspects are going to feel very much like RDS, and so you'll be very comfortable in that environment. And if you're coming from the OCI side, we're going to be using the OCI infrastructure, and so you're going to be very comfortable with this environment. Our goal is to be able to give you the best of both worlds. On the open source side, one of the features that is the most fastly adopted feature for Aurora is Aurora Serverless v2. Aurora Serverless v2, or ASV2, allows a single instance to scale up and down in real time based on your actual workload. So if your system is not busy, we're going to shrink the size of it, and you're not going to pay for that extra capacity. One of the things that we are offering this week and adding this week into that is the scale to zero. So now, let's say you have a test and dev system, and you're not using it on the weekends. On the weekends, that will automatically scale to zero, and you're only going to pay for what you're actually using. So that's the fastest adopted feature. What makes it even more amazing is the fact that Aurora continues, and this is now a decade of Aurora. Aurora continues to be the fastest growing service within AWS. And the serverless is now a key piece of that. But we see some customers that are needing to scale beyond the bounds of a single Aurora instance. And so for that, something that we just have released as generally available is something called Aurora Postgres Limitless Database. Now, this is a managed sharded solution. And so what we're going to do is when you need to expand beyond the confines of a single instance, we're going to allow you to have multiple instances. And when you create a table, you will give us the information, some number of fields that we can use as a sharding key. And when you insert rows, we'll look at the data in the row, and we will put it through the hashing algorithm, and we will send it to the appropriate shard. As your system scales up and down, each of these shards is an Aurora serverless instance. So each shard, if one shard is busy, it can scale up. If other shards are idle, they can scale down. If overall your system is becoming full and you're going to need more shards, then this solution will automatically add transaction routers as needed and automatically add shards as needed. And again, each one is an Aurora serverless instance, so they're independently scaling up and down. This allows you to get into petabytes of data storage and millions of write operations per second. In addition to features for scalability, let's talk about some features for improving ease of use. The first that I wanted to focus on is sometimes people are using one technology and they would like to be using a different database technology, maybe to increase scalability or some other aspect. We have our data migration tool, and it's able to read the source and the queries that you're running in your existing environment and convert it into your target environment. And this is showing that when we have problems converting from the original without AI ML processing, we now have the ability to use AI and ML to be able to help us convert the queries. And this on the screen has been an example of that. But let me do, so this is AWS data migration tool, and let me do just a quick demo here. On the left-hand side, let me orient your eyes. You've cracked open the database. We've gone in and we have found all of the schema, the stored procedures, all of the different things for this database. We have run a conversion across all of it. And what you see here is we're having one particular view definition that we are not able to successfully translate. So what we're doing is we're going in and we're going to generate a Gen AI-enabled solution. It's going to find a solution and put it on the right-hand side here. We've gone in. You have the ability to edit it. And here we're deleting a comment that we had found an issue. And we're saving that and applying the changes. And now the entire database can be moved from the source database to the target database. So again, this is the latest version of DMS. This is where you will go and basically your console for doing these types of heterogeneous migrations. In the space of vectors, when I was here last year and we talked about vector databases and did a complete walkthrough, I talked about the fact that we had fundamentally made a bet on vectors. And that bet was we had a choice of should we produce a vector database or should we enhance our existing database offerings with the vector capabilities. Now, we made a choice. Now, if you were to go to Bedrock, you would be able to see some of the best vector databases that are out there, so you can totally use that if that's what you would like. But our choice for our services was that we decided that we were going to enable vectors across a wide portion of our portfolio. And the reason that we did that was we wanted you to be able to use the technology that your team is already familiar with. We wanted you to be able to store the vectors close to the base data, if that's what you wanted to do. And perhaps you wanted to avoid the cost of additional licenses within your portfolio. In doing this, we have seen tremendous success in this approach, and we have tens of thousands of instances of people using these capabilities across all of these different technologies. One question I get asked a lot, though, is, it's great that you have all of these different choices. Which one should I use? Well, if you're not interested in the ultimate in performance or the highest recall rates, you're welcome to pick any one that you would like and do it based on your own preferences. But many people are looking for the ultimate in performance, and they're also looking to make sure that they're getting the highest possible recall rates. And in our benchmarks across all of the technologies that are available in AWS, Amazon MemoryDB is a clear winner. So if you ask me for a recommendation, I'm going to give you Amazon MemoryDB as a great choice. With that said, let me introduce Eric Peters from the NFL, and he's going to talk about how they're using some of these different technologies. Welcome, Eric.
Thanks, Jeff. I'm happy to be here today. Our vision is to grow the game and unite communities around the sport of football by delivering the world's most exciting experiences. The fans just can't get enough. This past year, we had a record-breaking 123 million viewers watch the Super Bowl. Broadcasters, players, coaches, and fans alike are consuming next-gen stats like never before. And our game plan is for our team of content creators to put out the best possible content across all of our platforms to give the fans more of what they want. Over the course of our partnership with AWS, several powerful tools have been created that assist us in stat lookups on a day-to-day basis. But the process of finding the right media assets that align with those search results have always been very manual, multi-step process for our content creators. With over 1 million assets and constantly growing, it really can be like finding a needle in a haystack. Users would set filters to get a list of plays matching their criteria. Then they would have to manually search through that list to find assets associated with the play within the asset management system, all very manual. Now imagine doing that process 10 to 20 more times just to assemble a single edited package. With the coming of generative AI, we saw an opportunity for our content creators to be able to revolutionize how they're searching for play-based media assets through the use of natural language search. Instead of users choosing the search filters, we wanted to put the onus on an LLM to take a natural language query from a user and decide what API calls to make for that user. So let's open up the playbook for a play-by-play on how we were able to drive this idea down the field for a touchdown. In just under 4 months, we were able to go from idea to execution, building a play search chatbot we refer to as Playbook Pro that lets our users leverage the power of Amazon Bedrock and the Anthropic Claude models using the architecture you see on the screen. But in order to unlock the full potential of this solution, we needed the help of a new, innovative service like vector search for MemoryDB. We're using MemoryDB for both short-term memory during the execution of the queries and long-term memory for saving successful queries to the vector store to be leveraged on future searches. We can use these saved memories to guide new queries to get the results from the Next-Gen Stats API quicker and more accurately. As time passes, these successful user memories accumulate to make the system smarter, faster, and ultimately a lot cheaper. In this Playbook Pro example, we can see that our user is looking for Seahawks touchdowns in the fourth quarter this season. Over the course of about 30 seconds, you can see updates coming from the WebSocket API. This tells the user exactly where they are in the answer retrieval process, from determining the correct NGS call to make through to the formatting of the resulting data. Once the results come back, you get both the summary of the stats it found and a full list of the plays. From there, the user can click on the media portal link for any of the plays to access every available angle that we have access to in our asset management system. This takes the number of results down from that million to a few. One of the keys for us on this project was to get to a testable version of the application quickly. The faster you can get the application into the hands of beta testers, the more you can iterate on your solution to make the application as useful as possible for your end users. And by using MemoryDB to save positive past interactions into long-term memory, we're able to avoid the need to fine-tune a model. We immediately saw the value, returning more accurate results to similar searches faster. Playbook Pro is now allowing our content creators to have near instant access to the plays they're searching for like never before, which ultimately means being able to work up to 20 times faster. In a live production environment, that's a huge deal. With this solution, we're letting our content creators spend more time in the creative space and less time needing to get there. The sky really is the limit as we continue to iterate and develop this product. And we're already exploring ways that we can get this into the hands of the fans directly. Thank you.
Thank you very much. All right, I now know who to go to for help with my fantasy football team. So thank you very much, Eric. That was awesome. It was so cool. And I'm going to be sharing these stories at the next football game with all of my family and friends. All right, retrieval augmented generation. This is a way to take your information and combine it with the wonderful capabilities of a large language model. And last year when we talked about this in depth, we talked about being able to do fact lookups and vector search. One of the things that's really coming into importance is that we continue to improve the relevancy of the answers that we're getting in this environment, and just as importantly, the explainability of those answers. One way to do that is with something called GraphRag. And here's an example question. What are the sales prospects, for the sale of toys in the UK? And let's say we have collected some documents that we want to be able to analyze and use Gen AI on to help us answer this question. Here are the documents. We'd go through the standard process, and this is an automated Bedrock workflow of chunking those, creating entities, but now we're going to be doing it in a graph database as opposed to a relational database. The chunking process then creates entities that we are putting into the graph. And what's new and different, that's basically the entities in this chart 0 through 10 are the type of thing that we would be able to do with a standard database. With a graph database and something called a knowledge graph, we're able to then infer things from the documents that we are reading in. And we're able to create additional relationships. In this case, it's represented as fact 10. So what we're doing here is actually improving the ability for these models to respond. And in the same frameworks that we have talked about in the Bedrock workflows, we now have the ability to add graphs as a technology in and get the benefit of the GraphRag solution. What we're announcing is the fact that Amazon Neptune has been fully incorporated into Bedrock in these workflows, and you now get the ability to use the capabilities of GraphRag along with your vector databases. Let's take a moment, and I would like to introduce Céline, and she is from the BMW group, and she's going to tell you how BMW is using these technologies. Céline? Welcome.
Well, hello. When you think of connected cars, what comes to mind? Do you envision cars communicating with one another? Or perhaps do you recall the last time you paired your smartphone with your car? Well, my name is Céline Laurent-Winter, and I'm the Vice President of Connected Vehicle Platforms at the BMW Group. And our mission is to connect your car to the rest of the world and other cars, and processing and interpreting data to enhance our customers' seamless digital experience. And thinking of our customer seamless digital experience, I immediately consider the importance of data traffic, infrastructure, reliability, operations, and security. We introduced BMW's first connected car more than 20 years ago. Today, we have a very large connected fleet with more than 23 million connected vehicles and 95 connected drive markets. Worldwide, we are updating more than 9 million vehicles over the air on a regular basis. We manage 14 billion requests with over 1,300 microservices and process 195 terabytes of data traffic per day and send it to the fleet with remarkable reliability. And these numbers continue to grow. Our future vehicles will possess enhanced capabilities which will require even more relevant data. Our backend infrastructure relies on numerous virtual cloud instances, storages, and databases. We operate these 24/7 worldwide with a reliability rate of 99.95%. It's crucial to find a cloud infrastructure that scales and the right operation model. AWS has been a reliable partner for a long time. With increasing data privacy regulations, we created a powerful vehicle data collection platform that collects all relevant data from the vehicle according to customer preferences and consent. It cleans, transforms to the standardized vehicle signal specification, and continuously streams data to the backend services via a central API to provide the most updated vehicle status. Everything based on AWS infrastructure. We also built a specialized connected AI platform for automotive data, combining open source tools and cloud services. We use this to train our own models with BMW data, and we tailor partner model to meet specific needs. Our goal is to create a scalable, standardized, and managed AI infrastructure. It continually expands its capabilities with new AI use cases. To manage data at scale and meet the regulatory and business continuity requirements, we embarked on a multi-year modernization journey with AWS to build towards a serverless database architecture. We worked closely with AWS to ensure we designed an architecture that would easily scale to meet future demands, as we expect that the numbers that I show you will triple in the next 2 years. So our design uses multiple purpose-built AWS databases to power the foundational components of our connected vehicle backend. For example, Amazon DynamoDB is used for its single-digit millisecond speed performance to power the vehicle connectivity service discovery mechanism. It's fully managed, and the serverless design allowed the teams to reduce operational overhead and scale automatically based on active vehicles. And it has point-in-time backup features. Amazon Neptune is used as a graph database to visualize and persist graph queries for a GraphRag solution. Today, all our data from connected vehicle fleet is stored in the Cloud Data Hub, BMW's central data lake. It stores more than 4,300 data sets and 1,300 use cases across BMW. To extract more value from our company-wide data lake, we partnered with AWS Industries prototyping team to build Maya. It's an AI-powered assistant that uses Amazon Neptune with LLM to enable semantic search and relationship discovery across our dataset metadata. Amazon Aurora is used for its performance, availability, and scalability of mission-critical workloads throughout the connected vehicle systems. Most recently, we modernized our customer messaging system, called BMW Messages, to use Amazon Aurora Serverless V2. Let's dig a little bit more into Aurora Serverless V2. With millions of vehicles sold worldwide, we manage a vast amount of vehicles data every day. We use BMW Messages to send important updates and notifications to our customers across many different channels: in-car, SMS, emails, the My BMW mobile app, for example, for over-the-air updates. To handle the high demand of messages, we needed a high-performing and scalable cloud solution to process and store huge amounts of data, including transaction logs between our systems and customer vehicles. We trust Amazon Aurora for delivering the speed and availability of high-end commercial databases at global scale. So it was an easy choice to migrate our own premises databases to Amazon Aurora. we opted for Aurora Serverless V2, which scales instantly to hundreds of thousands of transactions in a fraction of a second and improve our reliability up to 99.99% availability. And scale back down during non-peak periods to avoid overpaying for unused resources. Since the successful migration of BMW messages, we have unified our international architecture to improve global connectivity and interoperability. Next, we plan to move the entire messaging service infrastructure to a fully serverless architecture. This way, we will continue to optimize cost and improve the reliability and scalability of our systems, and free up more of our developers' time to focus on innovation, adding new features to enhance our customer experience and get us closer to our vision of a managed AI infrastructure. Finally, today, we leverage machine learning across our connected vehicles, and as we look towards the future, we are excited about the possibilities generative AI unlocks for connected vehicles. The iVision D is a truly digital emotional experience. D adapts to the driver's wishes and requirements and uses information from previous journeys or social media profiles. Many different AI use cases are contributing to this vision. Here are 3 examples that I'm excited to share. Do you remember the last time you parked in the sun and had to enter in a heated car? Predictive preconditioning is a smart use case that will solve this issue for our customers in China. The intelligent personal assistant knows when you will come back to your car for the next journey and provides you beforehand with a preconditioning recommendation via a My BMW app notification. That way you can cool down your car on time. Your next departure time is predicted by a machine learning model. The model is trained with your historical mobility data like drive start, end time, distance, duration, speed. And we onboarded this use case on our connected AI platform in 2023, and it's already available for our customers in China since July 2024. Now, is your car self-sufficient? To ensure our customers' mobility, we have a service promise that we call proactive care. The proactive care intelligent assistant collects and processes data to ensure that your car remains in good condition and always up to date. It monitors the fleet, detects anomalies, and resolves issues before you even notice them. It truly cares for you. And what about Gen AI in our vehicles? We are already experimenting with first ideas on individualized experiences. Images are generated based on the vehicle situation by a foundation model in the backend and automatically displayed inside the car. Next levels of generated content are in the pipeline to create a full immersive experience. This is the D-vision becoming true. The common infrastructure for AI use cases is provided by our connected AI platform, hosted on AWS infrastructure. And let me give you an outlook what we have coming up for you. I showed you some examples where we are using machine learning and Gen AI to offer best-in-class digital experiences. And this is the BMW Nair class that will be launched in 2025. With the Nair class, we will be providing a new digital user experience, personalized and intelligent. So stay tuned for more things to come. Thank you and enjoy re:Invent.
Thank you, Céline. All right, we're running a little bit hot for time, so we're going to go quickly here. One of the things that I always like to highlight, 1,399. If you're wondering what that number is, that is the number of AWS open source contributions during 2024. That includes code reviews, code contributions, and governance. I'm personally passionate about supporting the open source space, and this has been a great year across a whole bunch of different ways to open source communities. Let me very briefly touch on two. One, collations. In the Postgres space, collations are outside of the database. An upgrade to the operating system could break a collation sequence. We work with the Postgres community and solved this problem and hopefully averted disasters for many customers around the world. And I'm going to try to go through this quickly. In terms of Valky, Redis was an open source database who in 2024 decided that they were not going to be open source anymore. We participated with the industry, with GCP, Oracle, the Linux Foundation, and all of the Linux providers to come up with Valky, which is an open source replacement for Elasticache or for Redis. And we have now incorporated that into Valky 8.0, and that is now part of Elasticache. And very briefly, it's 5x faster than prior versions. And just real quick, we always strive to find ways to reduce the cost of our infrastructure. And so these are cost savings coming to you that are now live on the website, where we have just simply dropped the price of these particular functions, including Elasticache serverless for Valky and DynamoDB global tables. In close, G2 used the word effortless. Effortless is a journey and not a destination, and we're on a path. Our goal is to find the things that the most advanced users of the database community are doing and use software to automate them in our environment so that everybody can do that. I hope you've seen features like that throughout the presentation today, and you're going to continue to see it at AWS. So with that, let me thank G2, let me thank Sanjay, Eric, Céline, and I want to take one moment to thank all of the developers who produced all of these features. And just take a moment and call them out. I also want to say thanks to all of you for physically being here or watching it on the web afterwards. So thank you very much. Cheers.